All right, what do you guys want to see from the review? Number 15, absolutely. No hesitation. Right, number 15, how are traffic delays related to the number of cars on the road? Below is data on the total number of hours of delay per year at 10 major highway intersections in the western United States versus traffic volume measured by average number of vehicles per day that pass through the intersection. Describe what the scatter plot reveals about the relationship between traffic delays and number of cars on the road. So they're asking you to describe that relationship, that association, that correlation. Does it look positive or negative? Positive. Strong, moderate, or weak? I'm going to go with moderate. Moderately strong or moderately weak? I'd say moderately strong. And then form. I would say linear. Unless it has some other very obvious shape to it, we're going to go with linear. So my answer here would be there appears to be a moderately strong positive linear relationship between traffic delays and number of cars on the road. Sorry for my messy handwriting. Suppose another data point at 200,000, comma 24,000 were added to the plot. Okay, so I'm going to add this with a blue dot. 200,000 on the bottom, 24,000. So right here. What effect, if any, will this point have on the correlation between these two variables? Yes.
It's not going to be like, I think it'll like move the line up a little bit.
Yep. Yeah, like my line of best fit's going to be somewhere in here, right? Without that dot. With that dot, it's going to it's got to move a little bit. Something's going to move up, whether it's going to tip or just shift. Is it going to strengthen or weaken my relationship? Weaken. Why? Yeah, like if it was somewhere in this cluster of dots, that would make it look more like a line than it did before, right? But it's way out here. So I would say it's going to weaken the correlation or decrease the correlation between the two variables.
Thank you.
You're welcome. Because it doesn't follow the roughly linear pattern of the other points. All right. For part C, we're going to look at that circled point on the scatter plot. If you were to kind of ballpark, and I'm going to ignore this guy for this part, because that was just our, like, suppose we added this point. Where would you ballpark a line of best fit? Like, would that be a good line of best fit? That? That? Like, tell me what to do with it to make it more like the line of best fit. Raise it a bit, so like this. Tilt it. Like that. That's better. Okay, so like, again, I'm just kind of ballparking this because they asked me a question about the residual. It says, is the residual positive or negative? Well, with where I've ballparked that line of best fit, I mean, even if I was really off and I said it was here, that point is above or below the least squares regression line. Above, which would mean what about the residual? It's positive. The predicted would be on that line. The actual is coming from the point. So we would say that it is a positive residual. Hold on, I'm going to grab this guy. Pop him down on the graph over here. So something like this. So I would say positive residual. If we used our least squares regression line to estimate the average vehicles, would our prediction overestimate or underestimate the observed average? It's going to underestimate. Remember, a positive residual means the actual is bigger than the predicted, which means my predicted didn't get high enough. My predicted was too low. If I have a negative residual, then I predicted too high because the actual was smaller than my predicted. So a positive residual is an underestimate. A negative residual is an overestimate. If we removed that point, what would it do to the slope, the y-intercept, and r? If I got rid of this point entirely, does that strengthen or weaken my correlation? Strengthens it, because that's not really in the pattern, right? So if I take this away, it's going to strengthen it, which would be which piece of this if I'm talking about strengthening or weakening? R. So would that increase or decrease? Increase. Thank you. What would it do to the slope? Decrease. If I take that point out, like right now, that point is pulling my line up higher. So if I take that point out, my slope is going to decrease. I want you to think about this like a teeter-totter, because I'm not taking out points on both sides, right? So if we're like this, and I take this point out so that my slope decreases, what happens to my y-intercept? It's going to increase because my line is going to tilt, right? So this is going to increase. Right. And then down for D through F, we have some mini-tab output. We're supposed to identify the slope and then interpret the slope in context. So looking at this mini-tab output, where do I go looking for the slope? Vehicles per day. This is my X variable. So this right here is my slope. So the slope is 0.07822. Let's interpret that in context. I'm going to write my little thing off to the side. Slope is the change in y over the change in x. What are the two things we're comparing here? We're comparing vehicles per day and hours of delay. So is the model predicting an increase or a decrease? Increase. So this is a predicted, super important to say predicted, increase because it's a positive slope. A predicted increase of 0.07822 what? Is it telling me about an increase in x? Or is it telling me about a predicted increase in y? What are we predicting with our least squares regression line? Are we predicting x or are we predicting y? We're predicting y. We know our x value. That's something that we can go out and collect, but then we are predicting the traffic delays. If you go and look at this guy right here, this is going to be my known. This is what I'm trying to predict. Let's see if I can make that a little bit smaller here. There we go. That's what I'm trying to predict. So it would be a predicted increase of 0.07822. What is my y? No, sorry. What is my y variable? My apologies. Hours of delay. So we have a predicted increase of 0.07822 hours of delay. For every additional vehicle, yes. For every additional vehicle. You could say vehicle per day. Since they wrote vehicle per day, I'm going to go ahead and add that. Because they had it right here. They had that per day part, so I'm going to go ahead and include that. Anywhere I can grab those extra context pieces, I'm going to grab those and put them in. You could say for every one more vehicle per day. That would be fine too. We want to talk about how the x is increasing by 1, and then what's happening to our prediction for y. That's what my slope means. All right, we want to write our least squares regression line, LSRL. What is our y? Hours of delay. So I would have hours of delay hat, because that's what we're predicting, equals, what comes after my equal sign? Y-intercept. What is our y-intercept? Negative 3,629. Plus or minus? Plus. Why is it plus? Because it's a positive slope, 0.07822. And then what? Yep, vehicles per day. You could just write vehicles or vehicles per day. I would take either one. Yes?
So why is it that the constant is always the A value and then the second part is the B value?
Why is it always A comes first and that's your y-intercept, B comes second and that's your slope?
But like, why is the constant always going to be the A value?
Yes, the constant is your y-intercept. That's your A. Yep. Yep, because that would be our unchanging amount. It's the slope and the x value that cause change here. but that y-intercept stays constant. That's not moving. And then the line moves based on the slope and the number of vehicles. Predict the hours of delay per year for 48,000 accidents. So we just need to take this and plug it in. Paste this down here, and I'm substituting in 48,000. Yep. If you put y hat, you have to then say somewhere on there y hat equals, and you have to write out what y hat is. Oh, if you're solving, no, you can just do y hat. I'm just copying and pasting because it's easier here. And I just noticed that there's a typo here. Sorry. That should be vehicles per day, not accidents, because there's nothing else in here that says accidents. So my apologies for that. What did we get? Let's ballpark it out to 2 decimal places. 125 point, I didn't hear what you said after that. 56. Would that have units with it? Hours. And then they also said comment on the reliability of this prediction. Thank you. Comment on the reliability of this prediction. Well, let's go back and look at what we have collected data for. I have data starting, what, around like 180,000 vehicles? Is that right? Like if I'm reading this, like it's just a little bit below 200,000. It looks like they're counting by 20,000. So 180,000, 190,000 is the smallest piece of collected data I have for vehicles per day, all the way up to 320,000. Is this anywhere near my collected data? So would this be reliable? No. Does anybody remember what we call that? Extrapolation. Not reliable. Because it is extrapolation. It is far away from the rest of our collected data. Number 15. Oh my goodness.
So, R equals something. Does that equal the residual?
R? No. R is your correlation coefficient.
R.
It's telling you how strong of a linear relationship we have. Question, actually, to go along with what Maya just asked. If something has a really high R value, say like 0.99 or negative 0.99, does that automatically mean that a linear model is the best fit for the data? No. Do you guys remember when we learned how to graph those residuals and we saw that it made that U pattern? It was curved even though we had a really high R value. And so we said a linear model, like if I don't see the scatter plot, then I don't know. Even with a really high R value, a linear model wouldn't be horrible, but I can't say it's the best model just by knowing the R value. Did you have a question, sir? No. Okay, sorry, I thought I saw a hand go up. What else? Sorry, was that actually the end of 15? I don't remember whether it goes to the next page. Nope. It goes on.
Okay.
Oh my goodness. The problem that never ends. Calculate the residual for the average number of vehicles that is 250,000 vehicles and 13,000 hours of delay. All right, hold on. If I'm going to calculate the residual, what do I need? The actual. Residual is actual minus predicted. So I've got to go and look at that scatter plot to get the actual 250,000 vehicles, 13,000. Sorry, I don't need that. They gave me the number of hours, right? So here's my actual. $13,000. How do I get my predicted? LSRL. So we've got hours of delay hat is equal to negative 3629 plus 0.07822 times 250,000. And so what would our predicted be then? How much? 15,926. Here's my prediction. So what is our residual then? What'd you say? Oh, come on. Oh my gosh. Negative 2,926. How would I interpret that? Yep. You could say the least squares regression line overestimated by 2,926 hours, or you could say the actual hours of delay per low is 2926 lower than predicted. Yes.
So generally, in this test, we're not going to really have to worry about the T and the P.
Nope. Not for this test. We haven't learned how to interpret any of that yet. We don't even know what any of that means. So we're just going to ignore that that's there. Even this SE coefficient, we don't really need that.
What about the
R squared adjacent, no. Or adjusted, sorry, that's not adjacent, it's adjusted. We're going to use the R squared, not the R squared adjusted. Yep. Okay, so my interpretation again is the least squares regression line overestimated the actual hours of delay by 2,926 hours. What is the quantity of S? This one up here in my Minitab output, here's S. What is that measuring? It's the standard error of the residuals. So what does that mean? Like, talk to me like I've never walked into a stats class before. What'd you say? Very close. Yes. Yeah, so typically or on average, we're going to see that the prediction is about this far off from the actual.
So since it's positive, is it the prediction's higher? Or
S is always, so since S is a standard error, or calculated from a standard deviation, it's always going to come out to be positive. If you guys remember how we calculated standard deviation, we took the the difference, like we subtracted from the mean and then we squared it. So it's always going to come out to be a positive number. So whenever we calculate standard deviation, it'll always come out as a positive number. But that means that it could be this much too high or this much too low. Yeah, but this is telling me like, about how far off is your guess going to be using that least squares regression line. It's going to be about this far off. Sometimes you'll be more, sometimes you'll be less, but this is about how far off you would expect to be. So I would say that the least squares regression line will typically predict $3,899.57 hours of delay away from the actual hours of delay. Mm-hmm. Yep, you could invert that sentence. The point is, all of the predictions are going to be about this far away from what's actually observed. So if I wanted to know how good my guess is, if somebody's like, how far off are you probably? This is what you would say, like, I might be about 39,000 too much, or about 3,900 too much, or 39,000 too small. That's kind of my window of error here. How would we interpret R squared? This is a percentage, yep. Mm-hmm. 48.6% of the variability. What are we making predictions about again? Hours of the delay. So 48.6% of the variability can be explained by. Mm-hmm.
So, with a low S value and a high R squared value, if those two things like exist, does that mean that the LSRL is like
good at making predictions?
Yeah,
Yes. Yeah. If S is low and R squared is high, your LSRL is good at making predictions.
So in that case, we wouldn't have to use the scatter plot. It'd be better to look at it if we didn't have one.
Again, I'm not going to be able to say this is the best model without looking at the scatter plot. I could say this is a good model, but not the best. I really need more information to say it's the best. All right, 48.6% of the variability, sorry, I left out my context, in hours of delay. Can't leave out context. This is what happens when I talk and write.
Sorry.
No, that's okay. Can be explained by the relationship with average number of vehicles per day as represented, I know, right, by the least squares regression line. Okay, so if we take all the context out of here, you guys need the context in there, but what this sentence is saying is that changes that I see in the changes that I see in that y value, right? Changes that I see in hours of delay. When I see a change in hours of delay, it's because of this relationship with average number of cars. As average number of cars goes up, hours of delay goes up. As average number of cars goes down, delay goes down. We see this relationship. And almost half of the change that I see in those hours of delay is because of this relationship that we see in that least squares regression line, that thing that we're using to make these predictions with. Does that make sense? Okay. I realize it gets really wordy when we start putting our context in there because our variables aren't just like houses or cars. It's average vehicles per day and hours of delay. So that ends up making our sentence really wordy sounding. But if I was going to explain this to a boardroom full of people that look at this computer output and they're like, I have a headache already. Just tell it to me in English. That's our job in AP Stats, is to be able to take this computer output and interpret it back into English so that people can use it to make good decisions with. All right, a couple more pieces. Does it end at K? Yes. Okay, thankfully. Find and interpret the correlation coefficient. What in the world is the correlation coefficient? No, it's R. It's R. Correlation coefficient is R. They gave us R squared, so how do we find R? Square root it. So it's going to be plus or minus whatever my R squared is. So plus or minus 0.486. How do I decide whether it should be plus or minus? Increase or decrease. So did we describe it as a positive correlation or a negative correlation? Do we have a positive slope or a negative slope? Here we have a positive slope, so I'm going to go with positive R value. So my R would be what? I know it's 0 point something. I need the square root of 0.486. 697, and we went with a positive R value because of a positive slope, positive correlation. How would I interpret that then? What is it telling me? Yep, it's going to tell me about the general form, the direction, and the strength. So I would say the relationship. Pretty much, yeah. It's pretty much what we did from the scatter plot, only now I have a number to back up my moderately strong or very strong or what have you. The relationship between average vehicles per day and hours of delay is a moderately strong positive linear relationship. Yep, order does not matter there. If you said it's a linear relationship that's positive and moderately strong, that would be fine. As long as you hit those three pieces somewhere in that sentence along with your context. You have to talk about the context for both the X and the Y when you're talking about that relationship. And you have to hit those three pieces: direction, strength, form. R value can't tell me about outliers or unusual features. Remember, when I'm looking at a scatter plot, if I see any unusual features, I would want to mention those. Oh, this is a possible outlier because it's way outside of our pattern. You had a question?
So when it's over like 0.5 or 0.5, that's when you use like
Yeah, so like if I have a, like this one, 0.697, I'm going to say that's moderately strong. I wouldn't call it strong yet. If I had like a 0.48, moderately weak. Please keep in mind that a negative on the R value doesn't make it weaker. Negative 0.95 is very, very strong. It just means that it has this negative relationship, kind of like how many layers of clothing people are wearing and the temperature outside. As the temperature goes up, people start shedding layers of clothing. So it has a very strong relationship, but as one goes up, the other goes down. All right, last piece, finally. Below is the same scatter plot, but with the 6 intersections in California plotted as circles, and the 4 other Western states plotted as squares. Comment on how the relationship between average number of vehicles per day and hours of delay per year differs between the California intersections and the intersections in other Western states. So if I'm looking at just California, I'm going to use some different colors up here. California. So there's California. Other Western states, I'm going to do them in blue. What do you think? If you were going to compare slopes for those lines of best fit, do they have about the same slope? Does one have a steeper slope than the other? California seems to have a steeper slope. Than the other Western states. What's something else that we could comment on? We commented on slope. They're both positive associations. And in case I haven't made this clear, association, correlation, relationship, those are interchangeable. Those are all synonyms when we're talking about this. What else could we say? Give me anything else that you think we could say about this. What did you say? We could talk about the y-intercept. Which one appears to have a higher y-intercept? Other states. So the other Western states would have a larger y-intercept. Yep. Well, in this case, since we're at 200,000 here, I kind of have to mentally trace this backwards. So I'm looking at kind of like the line of best fit here. So there's like ish my line of best fit for other Western states. And there's ish my line of best fit for California. Do you see how if I follow this one back, it's going to go down a lot more? Right. I don't know if I have enough time to finish writing this out, but other Western states seem to have a higher y-intercept. Based on hours of delay and average vehicles per day, do you think it would be better to live in California or the other Western states? Other, why? They seem to have the most average vehicles and the highest delay, right? So you could comment on that also. So we just took forever answering one question. Answer key is posted in Canvas. If you get into Canvas and you go to today's modules, you have to go to the 920 module. you can find the answer key posted there, both on the page and then I think it's in the module just by itself.
Test is Friday, right?
Test is tomorrow.
I told
What?